Jai Hind. The topic which we are going to discuss today is OSI and TCP IP models. So first we will start with OSI model. These are the OSI and TCP IP models. They are basically meant for how the two systems they should communicate. So they decide the protocols and the rules. That is, when you are transmitting the data from system 1 to system 2, then what behind the scene the things are going on. And also when we talk about the OSI and TCP models, they are the layered architectures. That is, we are having the data is flowing from one layer to another layer, and lastly through the wireless or the wired communication it is reaching to other system. So communication, when we say the communication architecture, basically it talk about the strategy for connecting host computers and other communicating equipments. It defines necessary elements for the data communication between devices, rules, protocols, how the things to be done, what activity need to be done, how to make a session, how to do the compression, in which layer to do the error correction, and so on. So a communication architecture defines the standards for communicating host. A programmer formats the data in a manner which is defined by the communication architecture and passes it on to the communication software. Separating communication functions add flexibility. For example, we do not need to modify the entire host software to include more communication devices, and that is why we need the communication architecture. Now the communication architecture which we are going to discuss is a layered architecture. What it says? It simplifies the network design. That is, we are having the layers, and in each layer we are designing the rules, a set of protocols through which we are sending the data from one system to another system or one host to another host. It is easy to debug network application in a layered architecture network. That is, if some problem came in one of the layer, then we need to debug the things in that particular layer, and rest of the architecture remains untouched. The network management is easier in the case of the layered architecture. Network layers, they follow a set of rules, and these set of rules, they are known by the name protocols in networks. The protocol, it basically defines the format of the data being exchanged. That is, each layer is getting something from its upper layer. It is working on that particular data. It is formatting that data, and after formatting, it is sending that data to its lower layer or vice versa. Protocols, they also control and the timing for the handshake between the layers. Now comes to the OSI model. OSI model is basically given by the ISO organization, that is International Standard Organization. ISO established a committee in 1977 to develop a architecture for the communication communication architecture. OSI reference model is the result of this particular group. In 1984, OSI reference model was approved as an international standard for communicating between two hosts or multiple hosts. What the term open denotes? The open denotes the ability to connect any two systems which conform to the reference model and associated standards. OSI model is now considered the primary architectural model in the networks. It describes how the information or the data make its way from the application programs such as a spreadsheet, Word docs, multimedia, or anything through a network medium. Now this network medium, it could be wired or wireless, to another application program which is located on some other system. The OSI reference model, it divides the problem of moving the information between systems or hosts over a network medium into 7 layers, smaller and more manageable problem. Each layer, it is saying that each layer is managing some kind of activity or it is resolving some problem in the case of OSI. This separation into smaller, more manageable functions is known as layering. So, basically, OSI reference model is a layered communication architecture. These are the layers. At the bottom, we are having the physical layer, and at the top, we are having the application layer. Now, the physical layer, when we says, it is basically responsible for the binary transmission, that is a transmission of 0 and 1 bits. Data link layer, it provides access to the medium. Network layer, it basically provides the addressing scheme and it also tell which best path to be followed when we are doing the communication. Transport layer, responsible for providing end-to-end connections. Session for the inter-host communication. Presentation layer, basically for data representation. And the last one, at the top, we are having the application layer, that is the network processes to applications. So, the process of breaking up the functions or the task of networking into the layers, it reduces the complexity, and that is why we follow the layered approach. Each layer provides a service to the layer above it in the protocol specification. Each layer communicates with the same layer software or hardware on other computer. That is, if I am saying this is host 1, then we are having another system which is host 2. There also we are having the reference model. Here also we are having physical layer, data link layer, network layer, transport layer, session layer, presentation layer and the application layer. So, what this particular thing means, that is each layer communicate with the same layer. It says that we are having a logical connection between these layers when two systems they are communicating and so on. So, the lower layer 4 layers, that is transport, network, data link and physical, they are concerned with the flow of data from end to end through the network, that is up to here. What we are having? We are having a flow of, they are related how the data is flowing, and above that 3 layers, that is 5, 6 and 7, they are more oriented towards the services to the applications. Now, the data is encapsulated with the necessary protocol information as it moves down the layers before network transit. That is, when we are, this application, it is generating some data, this data moves here, and presentation layer, it encapsulates this data, that is it adds some information according to the protocols which have been decided at the presentation layer, and then after encapsulating that data into some other format, it sends that formatted data to its lower layer. Let's start with the very first layer, that is the physical layer. It provides the physical interface for the transmission of information. It defines the rules by which bits are passed from one system to another on a physical communication medium. It covers all mechanical, electrical, functional and procedural aspects for the physical communication. Such characteristics, what is the voltage levels, timing of the voltage changes, physical data rates, maximum transmission distances, physical connectors and other similar attributes, they are defined here, that is at the physical layer. Above that, we are having the data link layer. It attempts to provide reliable communication over the physical layer interface. And what it does, it basically breaks the outgoing data into frames and reassemble the received frames. So, once it receives the data, it did divide the data into frames, and if it is receiving the data from the sender, then it reassemble the received frames. It create and detect frame boundaries, handle errors by implementing an acknowledgement and retransmission scheme. These are the protocols. Basically supports point P2P, that is point to point, as well as broadcast communication. It also supports all three types of communication: simplex, half duplex or full duplex communication. Now the third layer from below is network layer. It is basically responsible for the routing of frames through the network. It defines the most optimum path the packet should take from the source to destination. That is the shortest path, sometimes we say, but it is not always possible. So we here say that we are deciding the optimum best path. It also does the logical addressing so that any endpoint can be identified. So logical addressing, it is being done at the network layer. It also handle the congestion, that is, if at the other end we are receiving a lot of packets, then how to handle all those huge volume of packets. It will create a congestion in the network. So it handle the congestion in the network. It facilitates interconnection between heterogeneous networks, that is, internet networking is being supported at this layer. The network layer also defines how to fragment a packet into smaller packets to accommodate different media. Above network layer, we are having transport layer. The basic purpose of this layer is to provide a reliable mechanism for the exchange of data between two processes in different computers. So, how it does? It ensures data units are delivered error-free, error checking is being done, ensures that the data units are delivered in the sequence, that is, sequence to be maintained. If some packet got lost, then transport layer is responsible basically to tell the network that some bad has been happened in the network while receiving the data. It ensures that there is no loss or duplication of the data units. Sometimes a packet reached to the destination through multiple sources. So, your destination, it could have the multiple same number packets. So, transport layer is basically responsible to identify such duplicate cases and to drop the duplicate packets and retain only one packet. It provides connectionless or connection oriented service, that is, it supports both type. It have the protocols corresponding to connection oriented as well as corresponding to connectionless. It provides for the connection management, multiplex multiple connection over a single channel. It is also responsible for this activity. Session layer, it provides the mechanism for controlling the dialogue between the two end system, that is, it is basically responsible for building the session, that is the handshaking activity. It defines how to start, how to control the conversation and when to end the conversation. And this how to start, controlling and ending the conversation, this whole thing is known as a single session. And how it does achieve this purpose? This layer requests for a logical connection to be established on end user request. Any necessary logon or password validation is handled by this layer. Sometimes a session layer, while doing the handshaking, it requires some additional information. So that additional information to be exchanged at this layer. This layer is also responsible for terminating the connection. For example, if you have seen that if you log in the railway website and after some time automatically session got expired. So basically session, and this activity is done by the session layer. This layer provides the services like dialog discipline, which can be full duplex or half duplex. It also provides checkpoints mechanism such that if a failure occur, then the data can be retransmitted from the last checkpoint. That is the data recovery. Session layer is also responsible for data recovery through checkpoint mechanism. Above that, we are having the presentation layer. It basically defines the format in which the data is to be exchanged between the two communicating entities. It is also responsible for compression and the encryption. That is, the data compression and the data encryption is being done at the presentation layer. At the top, we are having application layer. It interacts with the application program and is the highest layer of the OSI model. This contains the management functions to support the distributed applications. For example, some example of application layers are, for example, you are sending a mail, or you are doing file transfer, or you are doing remote login from the telnet, etc. So, application layer, we are having the applications at the application layer for exchanging the information between the host devices. This particular figure, it is showing how the interaction is being done between the two systems or between in a network by using OSI reference model. So, here we are having a device A. Let's suppose it is sender. Here I am having device B. Let's suppose this is my receiver, and here I am having the intermediate nodes. These nodes, they can be my routers, they can be my gateways, that is the nodes which are responsible for forwarding the packet from one node to another node. Now, at both the devices, all these layers, they are active, but at the network devices which are acting as a intermediary nodes, only 3 layers they are active, that is physical, data link and the network layer. At the device, application and between presentation, this interface is known by 7/6 interface. So, accordingly we are having the interface between each immediate layers. There is no interface between layers like this. Layer 1 is communicating with layer 3, there is no such kind of thing. Layer 1 is always communicating with layer 2, or layer 2 can communicate with layer 1 as well as can communicate with the layer 3, but layer 2 cannot communicate directly with layer 5, layer 6 or layer 7. So, here as we have seen that each layer will communicate with its corresponding layer on other device. So, here when you route a data, your data is being received, your data flow like this. Application layer generates the data, then presentation layer, it does compression, encryption and so on. Now, this thing goes to session will do something here, then it will transmit the data to transport layer will transmit the data to network layer will transmit the data to data link, and from here we got the data to physical layer, and we knew that the physical layer is basically responsible for transmitting the data, binary data. So, when it transmits the data, first your data go here, your physical layer, it will do some activity, your data goes here, then again from here to here, from here to here, and then we receive the data like this. So, here these two layers, they communicate with each other, here they too, similarly this kind of communication is being established. Now, from transport layer, that is the fourth, there is a direct communication between the two transport layers, between the sender as well as the receiver. So, here we are having peer-to-peer protocols at the fourth layer, similarly at fifth layer, sixth layer and at seventh layer. Here there is no layer from the intermediary nodes, they are being involved. So this is how the exchange of data being handled. Your data at the layer 7, it will do some encapsulate the data, further encapsulation, and like this until we reach to the bottommost layer. Now it will transmit the data to the physical layer, and if there is a direct communication, there is no intermediary devices, and if my receiver end it receives the data, then it will start reversing the things. Now this slide basically shows how the things are being done. So a message begins at the top and moves down the OSI layers to the bottommost physical layer. As the message descends, each successive OSI model layer adds a header to it. A header, basically it is a layer specific information that basically explains what functions exactly what that particular layer has done. So conversely, at the receiving end, headers, they are removed from the message as it travels to the higher layers. So here, for example, this is my TCP IP layer, which I will show later on. So here, application presentation and the session layer, they will generate a PDU. Transport layer, it will generate a segment. It will break down the my information into segments. Segments, they are further when the network it does the processing on the segment, it will generate a packet. These packets, when it reach to the data link layer, it converts it into frames. Now these frames, when they reach to the physical layer, they are convert it into bits. So here at the receiving end, when the bits received here, my MAC header is sitting here. So here when we go to the data link here, the header which is being attached, it is my MAC header. Now this MAC header, it comprises of LLC header, IP address, TCP address, your TCP and the upper layers data. Here we are having the network layer. Here the header is known by the name LLC header. It comprises of IP, LLC header. Now it being dropped here. Now when it reached to here, it is comprises of only IP, TCP and the upper layer data. When this layer moves to the upper, when this particular information reach to the upper layer, here the IP header is removed. Only TCP and the upper layer data left. When it moved to the upper layer, then TCP header got removed. Here we are having the upper layer data and ultimately this data is presented to the user. So here the sender is sending the data, we are having the upper layer data. Here the segment, it comprises of TCP header and upper layer. Packets, they are basically IP header is being attached, then we are having the data link layer, LLC header or the MAC header depending what I am doing. Then at the physical layer, we are having the bits. Although we have seen in the layered approach that if we follow the layered approach, then the we are reducing the complexity. Also, if some problem comes in one of the layer, then the debugging becomes easy. But yes, the network approach, layered approach do have some problem. 7 layers, they are not widely accepted, standardized before implemented. Top 3 layers, they are quite fuzzy. Internet, so we are having another model, that is TCP IP model. So basically it is the set of communications used for the internet and other similar networks just like your OSI. It is named from 2 of the most important protocols. These are the most predominant protocols in my TCP IP protocol suite. One is TCP, that is transmission control protocol, and the IP, that is internet protocol. These are the multiple layers of network protocols when we are saying. So we are having a user process which may be a web client, then the TCP protocol, the data being operated with TCP, then this being operated with IP. Then we are having the internet drivers, the data is being sent here. It may be my Ethernet LAN or something. So these being received by the Ethernet drivers, then IP protocol, above that we are having TCP protocol, and the information is being presented to the web server. If we are having multiple layers of the network protocol, for example in routers, then we are having the host system routers. These routers will transmit the data which will form a WAN, and here maybe we are having a LAN. Now this shows that is how the OSI and TCP IP models related to each other. In the OSI model, we have seen that these 4 layers, they comprise of the data flow layers. Above that we are having the application layers. Similarly, when I am saying the TCP IP protocol suite, then the physical layer and the data link layer, it is my network interface. Above that, network corresponding to network layer, I am having again network layer. Corresponding to transport layer, I am having the transport layer, and the session presentation and application in the TCP IP protocol suite, we are having a application. Correspondingly, we are having a application layer. Let's see how the things are being done. At the physical layer, that is we are having physical media. Above that, DLL, that is data link layer. Management of cost effective and reliable data delivery, access to physical networks, these are the things being handled at this layer. Above that, network layer, IP addressing, handling of the datagrams, routings, congestion, this being done here. Transport layer, here 2 protocols, either TCP or UDP, they operate. Basically, they are responsible for end-to-end message transmission, error detection and the error correction. And application layer, as usual, application programs using the network. So here, how the TCP IP protocol stack works. So here we have seen earlier that we are having a network connections from host A to host B, and we are having routers, network devices. So from application to transport to internet to link layer physically, then the data is being transmitted to the Ethernet to my router. From router, only 2 layers they work, link layer and the internet layer. Then data through fiber optic cables or satellite, something like that, it reached to the second router, from here to Ethernet, then to the receiving end. So these are the TCP IP protocol suite. If we say these are the protocols which are defined by the underlying networks, that is host to network. At the IP level, IP layer, basically it is responsive, the protocols which are applicable here, work here, it is my ICMP, IGMP, RARP and ARP. Then at the transport layer, 3 protocols basically we found, one is SCTP, TCP and UDP. Session, presentation and application layer, that is basically your applications. There we are having corresponding to application. So if I am sending a mail, then SMTP is there. If I am doing the remote login, then Telnet is there. If I am doing file transfer, then FTP is there. If I am doing the browsing activity, then HTTP protocol is there. If I am searching a name, then I am having the DNS protocol like this. So these are the protocols which are operable at the application layer. So these are few of the protocols which we have seen earlier. All the things have been prepared through the Frozen, that is the data communication and the networking book. So this is all about OSI model and the TCP IP model. Thank you and Jai Hind.